Imagine a universe with no sun, no moon, no oceans, no sky. Just a cold, dark cloud of gas and dust drifting through space. Now imagine that same cloud collapsing, igniting, and over the course of 4.5 billion years, becoming the world you're standing on right now. This is the story of how Earth was born, and it's more violent, more chaotic, and more miraculous than most people realize. About 4.6 billion years ago, our solar system didn't exist. In its place was a giant molecular cloud, a vast, swirling region of hydrogen, helium, and trace amounts of heavier elements forged in the cores of long-dead stars. Then something triggered a collapse. Maybe a nearby supernova sent a shockwave rippling through the cloud. Whatever the cause, gravity took over. As the cloud collapsed inward, it began to spin, slowly at first, then faster and faster, like a figure skater pulling in their arms. The center grew denser and hotter, eventually igniting nuclear fusion. Our sun was born, but not everything fell into the sun. The leftover material flattened into a spinning disk around it, what scientists call the protoplanetary disk. This disk was packed with gas, ice, and tiny solid particles called dust grains, and those dust grains were about to build a planet. In the inner part of the disk, close to the young sun, it was too hot for ice to survive. What remained were rocky and metallic particles, silicates, iron, nickel. These particles began to collide. Most bounced off each other, but occasionally particles would stick. Clumps formed. Clumps merged into larger clumps called planetesimals, essentially baby protoplanets, ranging from pebble-sized all the way to mountain-sized. Gravity then did what gravity does. The bigger a planetesimal got, the more pull it had, and the more material it attracted. This runaway growth process is called accretion. Over tens of millions of years, these planetesimals slammed into each other in massive collisions, building up 4 rocky planets in the inner solar system. One of them, still molten and chaotic, was the early Earth. Scientists call it proto-Earth. It was nothing like the world we know today. No oceans, no atmosphere, just a violent, churning ball of rock and magma, still growing, still being bombarded from every direction. About 4.5 billion years ago, proto-Earth had a catastrophic encounter. A Mars-sized planet, scientists call it Theia, was on a collision course. And it didn't just graze us. It hit Earth nearly head-on. The energy released was incomprehensible. The outer layers of both planets were vaporized and blasted into space. A massive ring of debris formed around what remained of Earth. And over just a few thousand years, an eye blink in geological time, that debris clumped together under gravity to form the Moon. This single event shaped Earth in ways we're still discovering. The impact likely mixed material between both planets, tilted Earth's axis to the 23-degree angle that gives us seasons, and may have delivered some of the carbon and volatile elements essential for life. The Moon we see tonight is a scar from the most violent event in our planet's history, and without it, Earth would be a very different and likely uninhabitable world. The Moon stabilizes our axial tilt, preventing wild climate swings. It drives our tides. It slows Earth's rotation to a pace that supports life. One catastrophic collision, endless downstream consequences. After the giant impact, early Earth was largely molten, a global magma ocean. And something crucial happened inside it: differentiation. Heavy elements, mostly iron and nickel, sank toward the center under gravity, forming Earth's dense metallic core. Lighter rocky material rose to the surface, eventually cooling into the mantle and crust. This separation matters enormously. Earth's iron core generates a magnetic field, a giant invisible shield that deflects deadly solar wind and cosmic radiation. Without it, our atmosphere would be slowly stripped away, just like Mars. Earth's layered structure, core, mantle, crust, is not just a geology textbook fact. It is one of the core reasons life was possible here at all. Early Earth had no oceans and a suffocating atmosphere of carbon dioxide, nitrogen, and water vapor from constant volcanic outgassing. Slowly, as the surface cooled, that water vapor condensed into rain. For possibly thousands of years, it rained. The first oceans formed, but volcanism alone may not account for all of Earth's water. A leading theory holds that comets and asteroids delivered much of it, icy bodies from the outer solar system that pelted early Earth during a period called the Late Heavy Bombardment, around 4 billion years ago. Destructive, yes, but those impacts also brought carbon and organic molecules, the raw ingredients for life. Eventually, early photosynthetic microbes flooded the atmosphere with oxygen in the Great Oxidation Event, permanently transforming Earth's chemistry and opening the door to complex life. So here's the full picture: a cloud of interstellar dust, a sun igniting, rocky particles sticking together, a catastrophic planetary collision, a molten world cooling and layering itself, oceans filling, an atmosphere forming. Earth wasn't placed here gently. It was forged through billions of years of violence, chance, and transformation. And every element in your body, the iron in your blood, the calcium in your bones, the oxygen in your lungs, was made inside stars that died before our sun even existed. You are, quite literally, made of stardust. If you enjoyed this, subscribe and drop a comment. What part of Earth's origin surprised you most?